Hello, everyone. Welcome to the Computer-Aided Technologies CATIpult webinar for SOLIDWORKS 2018 from top to bottom. My name is Dennis Barnes, and I am an applications engineer here at Computer-Aided Technologies. Basically, our webinar today, the title is Top to Bottom. We'll be talking about some techniques that are available for top-down assembly modeling. So let's go ahead and get started here. What I'd like y'all to do is if you have questions, please submit them via the chat, and we'll try to make time at the end of the presentation to get to those as well. If you provided an email address in your sign-in, we can also send those replies via email as well. So basically, I'd like to talk to you about the difference here between top-down versus bottom-up assembly modeling. The picture here on the left, this is an old style bicycle, used to be called a penny farthing because of the difference in the size of the wheels. And I'm going to be demonstrating how to take that bicycle and build it from the top down. Bottom-up assembly modeling, as is represented here on the right, this is an assembly from our Essentials class, where we take all the discrete components and we use the mating relationships to bring the components together and limit the motion inside the assembly to emulate real-world mechanism. The other difference here is that in top-down modeling, all of the assembly components and motion are created within the context of the assembly. Very few of the components are created outside the assembly unless they're already defined and built and exported and the references are broken and so forth. So what I'm going to be doing here is I'm going to be opening SOLIDWORKS and demonstrating how we start with the in context with a sketch picture and we build the assembly. And then we're going to move to another technique I'd like to show you called assembly layout, which begins also with kind of some sketch blocks and then goes straight to the assembly solids from there. And then we're going to move on to assembly layout. So let me just go ahead and get started with the SOLIDWORKS demonstration and you guys can see what we're doing here. So the first thing I want to do is I'm going to start with a sketch. So I have a sketch that I've already created here called the bicycle layout. And what I've done is I've created a couple of circles on a sketch here that represent kind of the size of the bicycle that I want to be in the end result. So I'm going to go in and edit the sketch. You'll see I've set the size of the large wheel to 42 inches and the size of the small wheel to approximately 16. We may adjust that once we bring in the picture. So now that we're editing the sketch picture, we're going to go ahead and start to bring in the sketch picture. Now that might have gone fast for you, but it's in the tool, sketch picture is what I'm selecting here. Here's the picture that I'm going to be using. It's a PNG. You can use JPEG or bitmap, whatever you have. I'm going to size it just a bit, but I'm going to use a special tool here to get it scaled exactly right. This is called the scale tool, and I'm going to place it about where I want to create the size of the wheel that I want. I'm going to put it right here in this corner. Then I'm going to take the other end of it, and I'm going to go down here. You'll notice I get a vertical indicator when that line is actually vertical. It doesn't set it vertical, but it kind of gives me a good guideline for having a vertical line. And then I'll set the endpoint there. Now I input the value that I want to match my layout. Then we move the image so that it matches up with the layout sketch. So there's the top of my layout sketch. Zoom in real tight so I can see it and try to put that right on. There we go. So now that I'm done, I can actually adjust the rear wheel. It looks like the size is really good. Screwed up. Get this back where I need it to be. Finish with the picture. If I need to readjust the size again, I can go back in on the picture, turn on the scale tool again, and then have it adjusted again. So here I'm moving the wheel, the rear wheel, back and forth to try to get it centered in the picture as well as I possibly can. That looks pretty good. Throw a dimension in here. This looks like 30.5. Okay. I want to go ahead and throw a couple of other references in here on my sketch. I'm just going to put in some sketch points to kind of help me move things along later. I want to put a sketch point maybe right here, and then right here for my maybe my frame or where I want my rim to start. Anything I add in here I can use later on down the line. So this looks like about 23. And then we'll go ahead and make this 2.5. And then I'm going to go ahead and put one more for where I want my rim to be, or not the rim, but the fork there, the top of the fork. I want that to be about 1 inch away from the top of the wheel. That's a good place for that to go. We'll go back here and add some more sketch geometry. I kind of want to set this up about 1 inch away from the wheel there. And I want to give myself some room for the fork. When I go to flatten the fork out, I'm going to need a position for that. So I want to give that about 3 inches, give or take. The idea here is to just kind of save myself some time later on when I go to create these other solids in here. Now that I'm done with that sketch, I'm going to use that sketch, the part, the sketch, and the layout into an assembly. Assembly inch, and then I just bring it in and let it set it at the origin. So now that I can see my layout sketch, I can see my picture, I can begin to add components in here. So the first component I want to go ahead and put in is going to be my front fork. So I insert a new part, I select the template, and then I select the plane that I want to put the part on. I'm going to go ahead and start on the right plane because that's where my fork is going to rely. It automatically starts a sketch for me, so I can go ahead and begin sketching here. Let's see, I want to go construction. There we go. Throw some dimensions on here. 1.75. 2.5. Now I'm going to go ahead and use this sketch after I split it here. For my sweep. I'm going to go ahead and use a circular sweep. 1 inch diameter is probably good for my tubular frame. By using the selection manager, it allows me to pick out individual sections of my sketch. Oh, 10 inches, way to go, Dennis. And there's our first solid in our part there. I'm going to use the plane of this end feature to create an offset at the origin. This is going to be the end of my fork. Oops. And I want to make sure the end of that is at the end of the sketch that I use for the sweep. So I need to show that. There we go. Since I'm going to use this for revolve, I only need half of this slot. That looks pretty good. Then I can just use a boundary with some end conditions here. We're going to go tangency. And then the next one will also be tangency. And then we can adjust that flatness by creating more tangency. So there's one body there. We'll go ahead and mirror that. Make sure you use bodies to mirror because we want the whole thing to get mirrored. There's the other side of our fork. I'm going to use this sectional line to sweep for my handlebars. The advantage of being able to use these sweeps, these individual sweeps, is that you don't have to have perpendicular sketches. Makes it really easy to just create the sweep. Come on. So there's my first part. Let me go ahead and show you how to put in the back fork. We're going to do something a little bit different than that. We're just going to get rid of that. We'll go ahead and rename this. This is now a virtual part. Call it the F fork. You can tell it's a virtual part by the little uptick right here. Now if I wanted to save it in my assembly, I could go ahead and put it in external file also. Same as assembly. So right now it's telling me I haven't saved the assembly, so I need to save my assembly. Save it as my bicycle assembly. And now we're ready to move on. New part. I'm going to go ahead and put this also on the front plane. And I'm just going to use a spline to go from here to here. That's going to represent the bottom half of my fork there. On the right plane now, I'm going to create a new sketch, and I'm going to create the fork sweep. I like to make that a construction line because it lets me get this double dimension capability. Okay. So I want the top of my fork to be even with this construction layout line that I made. What is my dimension twist on? Okay, so now I have two sketches. I'm going to use those sketches now to project a curve where I want my fork to be. So you'll see here's the curve, and I can use that so there's how I create the rear fork, half the rear fork. What I can do with this now go ahead and offset 3 inches. Make sure it's cutting the right direction. Here's where I'm going to put my the straight slot that I need for the end of the fork. Lost that dimension. There we go. When I destroyed the slot, it can cause some problems with the the organization of the part there. So there we go. Get out of the sketch, do the revolve. And I go back to my boundary. When you're selecting these boundary edges, it's important that you select the edges pretty close to where they're going to connect. Otherwise, it could get twisted. So you just really need to take a look at the preview there and see if you've got any twist going on in it. Otherwise, you may have to reselect or rechange your the points that you select on the edge there. Back to the bodies. Now all I have to do is connect it. We'll go ahead and start with a spline here that I'm going to use to copy the shape of this frame. Turn on the control polygon. This is the easiest way to control the spline. A lot of times, if you're not careful, you can actually get yourself in a lot of trouble if you just start messing around with the handles. This control polygon makes it really super easy to bring your spline right into the shape that you want very quickly. That looks really good. I'd like to go ahead and show the picture, the curve that I used, so that I can make my spline tangent to it. Makes for a much easier transition into the fork there. There we go. That looks good. Back to the sweep. This circular profile just makes things so much easier. And now, if I just hide my layout sketch here, wrong button. We've got a good start on the frame and the forks. I'm going to show you one more thing here. I'm going to go ahead and put in a tire. My tire I'm going to use, again, on the right plane. With my construction line there, I'm going to actually introduce a new technique here. I'm going to use a block that I saved for my rim. Get this oriented properly. need a construction line for the rotational axis. And now I have a rim. While I'm still editing that part, I'm going to go ahead and add another body to it. On the same plane, I'm going to introduce my block that I created for the tire. Just so happens they snap right at the same place, so it makes it real easy with the tire and the rim going together. Still need that rotational axis, otherwise it won't work. There's my tire. Rename that. Wheel. Now I need to create another one for back here, but the easy thing about this is I'm just going to create this as a configuration. So I'm going to open this part. This revolve sketch I'm going to edit here really quickly. I'm going to go ahead and delete the external reference, the one that's defined in context here. We'll delete that one. And that one, and we're actually going to put a dimension in here that I can use for my configurations. This will become my small wheel configuration. Specific to this configuration, this is going to be about my total wheel volume, so we're going to make this about 15. Let's start with that. That didn't work. So I must have changed it for both configurations by accident. So the default is there. Oh, I get it. I put in the radius instead of the diameter. Boy, these are easy mistakes to make, you guys. There we go. There we go. Back to my assembly. Bring in another wheel. There we go. And now I have that configuration set. and set the mate to keep the wheel in place. That looks great. So this is all I wanted to show you with this in terms of these techniques. What I'm going to do now is I'm going to open the completed assembly just to see what it looked like after I finished everything. So obviously there were lots of other parts that were created in context, some modifications to the fork, pedal, axle, spokes for the wheels, and so forth. But once you get this assembly in place here and you add a pulley relationship between the front and the rear wheels, you can actually have full motion in it like this. So I wanted to be sure and show you guys that, see how that worked. We're going to move right on into another technique that I wanted to show you, which was the in-context layout technique. So we're going to start with an assembly millimeters template. We're going to use the Create Layout button here. Rather than insert any parts, we're just going to start with a layout. This is actually, we're in a sketch in the layout here, so I'm just going to start creating my sketch to begin to build this layout. The important thing about layouts is they almost exclusively use sketch blocks. So after you create a layout sketch, you want to actually create a block right away. Then we rename the block to keep track of it inside our layout here. So see, I can move this block around. I'm going to go ahead and attach it to the origin and restrict the motion so that it won't rotate about that point. Proceed with another block here. This block is going to be my handle. I'm not going to worry about an insertion point because I'm using it right here, right now. Oh, I'm sorry, that's not the handle, that's the arm. Go ahead and put that right there. So see, I have motion with this one component inside my assembly already. I'm going to create another block that I can use and bring in anytime I want. So I'm going to go, I created a new part. On the front plane, I'm creating a sketch. And this is going to end up being my handle. I'll go ahead and make this into a block right now. This time I am going to put in an insertion point. Handle. And I'm just going to copy it. Go back to my layout and then just paste it. So there's my handle and my arm. Now I need a link to go between the two so I can get this motion started. So I'm going to go in here to Insert Block, and I'm going to navigate out to my Blocks folder, and I'm going to bring in my link. Once I create those attachments, now I have some motion here. I can control all the motion with the arm. One more inserted link, inserted block here. We're going to use the hold down. So now I'm looking pretty good here. I'm looking at my motion, and I see that my hold down doesn't quite go all the way down to what would be the floor of my clamp here. So what I want to do is I'm going to go ahead and edit this link by just double-clicking on it and changing the length of the link to give me a little bit more leverage in my assembly here. See, now my hold down goes all the way down to the floor. This is actually really great. So now I'm ready to go ahead and create a solid here. I'm just going to create one solid. I'm going to go ahead and make a solid out of my base. So I right-click on it, make part from block. I'm going to make it on the block. Correct template. Now I'm just going to go ahead and create a new sketch. I'm going to edit this component here and start a new sketch on the front plane and use my block to give me the layout information that I need. For this base here. Create some associations. Add some dimensions. Now I'm ready to extrude. I'm going to use a mid-plane extrusion, 20 millimeters. Okay. Go ahead and add a couple of fillets in here. Then I'm going to shell it. Using a 3 millimeter shell. Didn't mean to do that. Selecting the tangency will allow that to go all the way around to get the faces that I need. There's the part for my base. It's also in context, but it can be saved externally. So that's about all I have to show you all. I've demonstrated some techniques top to bottom, and let's talk a little bit about the pros and cons for each one of them. When you use the assembly layout mode, it's real easy for you to show motion. It's much more difficult to get 3 dimensions in the layouts, though, because you have to change the 3D sketch plane, and it can get really difficult. You have to also be careful to make sure that those associations stay on those 3D sketch planes. It can get out of control real easy. The other downside is you don't have the overall volume of the model to work from. So there's no sketch picture in the layout mode. When you do work from a sketch picture, you don't initially have motion in the assembly because you have to create that motion by removing the in-context mates that were created when the parts were created in the context of the assembly. So you just have to remember to delete those mates and then recreate them. And be very careful, because if you do have those other in-context relationships and you move the component around, it's going to reshape your part. So these are caveats that you just need to be aware of when you're doing top-down modeling. When you do go to use these as individual components inside other assemblies, you need to make sure and break the relationships and add the dimensions to define your assembly components. So right now I'd like to go ahead and open it up to questions that you might have. We've got a little bit of time left here, and I'll be happy to answer any questions that you have about top-down assembly modeling.
Hey, Dennis, we had one question come through the chat, and what is asking about the ability of constraining the scale to the sketch when you were utilizing the sketch picture.
Constraining the scale to the sketch. Well, what happens is you don't actually constrain the scale to the sketch, but you use the sketch to constrain, to create the scale. So it's really floating. Let me bring up that sketch again. Here's that layout sketch. When you're editing the sketch and you're working with the sketch picture, it's its own independent entity. So it can float around all by itself, and you can position it anywhere you want. This toolbar here, the scale tool, is actually used so that you can create the appropriate scale with your layout sketch. That's why I always start with a layout sketch, because it gets me the approximate scale for the overall picture that I'm using, or the overall volume of the assembly. It's not possible to actually constrain the sketch picture to the sketch. You just kind of have to get it as close as you can, because it's there to kind of help you get it in place and get the appropriate sizing and so forth for your assembly. Any other questions? All the techniques that I showed today are available in our regular curriculums for computer-aided technologies, SOLIDWORKS training. So if you attend our classes, you will get this training, and as you can see all the techniques there. A few more minutes here waiting for questions.
Got another question that just popped up, Dennis, about how do you control the tolerance? Now, I don't know if that's the tolerance of the picture or the model.
Well, tolerancing is going to have to be controlled with the discrete components. So once you get your components kind of in the places that you want, like I mentioned before, you're going to want to break those relationships and create them as their own discrete components, so that they all have their own dimensions. They're not really going to be in context anymore. The in-context editing is done specifically so that you can get things into the right place. Once you have all the components created, all the individual solids created, you actually have to break most of those in-context relationships to create the tolerancing. There are a few you might keep to help change sizing and so forth, but you're still going to want those reference dimensions along with their tolerances added when you go into a drawing mode. Good question.
Got a couple others that popped up here, Dennis, could the individual parts be broken out from this top-down type technique and reused for other assemblies?
Absolutely. That's what I've done, let me go back to this, this model here. So I've got another component that I created in the other assembly, and I saved it off as a discrete component. So I can actually just insert that. Let's say I grab the seat. Now, since the seat was created in the context of the other part, which is very, very close to the one that I created, it comes in fairly close, with the exception of maybe some changes that I might want to do. I might want to adjust the position a little bit. Right now, it's being put in a fixed location at the origin. So the origin for both of the bicycle models was right here, and just with some variation of how I created the position, the sketch, or created the other components, I have that component that was saved externally, and now I can put it in here. Now, the only thing that's got this in the particular position is that in context relation. So if I wanted to, I could float it, and then it could be used anywhere I wanted here. So I would go ahead and take a look at whichever plane and just create my mates based on those planes and so forth. And you just have to be careful that if you still do have those in-context relations, you might want to be careful with them, because they may end up causing problems with sizing. If the in-context relation is driving a size, like the wheel or the fork or something like that, and the original context changes, it could end up still changing the discrete component if the relations are not broken. Basically, you just break the relations and replace those orphan relationships with real dimensions and relations inside the sketches.
This is more of a general question, Dennis. What about opinions about maybe 50 or more parts in an assembly, and would these top-down techniques still be a good option for that type of a scenario?
I wouldn't use a lot of assembly components in context, because it becomes very difficult to trace and troubleshoot if anything does go wrong. What I would do is I would use the top-down modeling to get the basic major components in place, and then create the individual components maybe inside the context, but then break them right away and bring them back in and mate them, so that they're not being driven by the overall context of the components. Because, I mean, I'm going to be adding other components in here like fasteners, possibly, and other components that I may be downloading and using inside my assembly, and I wouldn't want all those in context. When you get above a certain number, it's going to start to get a little crazy. If you make a change, it starts a chain reaction that could cause undesirable results. That's just my personal opinion.
That looked like that was the last one that was waiting for me to get to in the chat, Dennis.
Okay. Well, I really appreciate y'all spending time with me today. From CATI, I do thank you. Hopefully this has been informative for you. You can use some of these tools and techniques. If you have questions about the techniques that were used, you can go ahead and dial us at 888-285-2284. That's our support line. General questions about SOLIDWORKS, we'll be able to handle those, and anything specific about this will get directed back to me. Hopefully this video will get posted somewhere. I'll talk to Chris about it. Maybe we can make an announcement of that so you can come back and watch it at your leisure.
Yes, all the videos will be processed and uploaded shortly. It just takes a while to get all that taken care of.